So the focus of this unit is actually on roots and powers and the relationship between the two. The first lesson was sort of a review from grade 9, but now we're going to sort of get into unit 1, which we're going to talk about something called radicals, and we're going to talk about how they relate to exponents, and we're also going to be doing some algebra with them. Okay? So before we start, like what we're going to do is we're going to get into roots, or what is often called radicals. Some of this is new, some of this is review from last year. Like you should be able to tell me what a perfect square is. What's that? Okay, which one's the perfect square? The answer, right? Right. Yeah, so a perfect square is a number that can be written as another number times itself. I'll give you an example. So which one's the perfect square? 16. Because 4 times 4. Another one. Avery? Okay, let's see. Sorry? 27? That's a different type of number. It's not a perfect square. That's actually a perfect something else. We'll talk about that later. 4. Because 2 times 2. Notice I said it's a number. I never said it was a whole number. Can somebody give me an example of a fraction that's a perfect square? All right. Fraction. You did them last year. Sorry? 49 over 25. Good. All you do is you just make a fraction up of 2 perfect squares. So this is a perfect square because it's equal to 7 over 5 times 7 over 5. And what's the square root of a number? Well, the square root of a number and it's denoted check mark with a little bar and something underneath. Okay. There's actually another way you can write square root. With a little 2. Okay. Those mean the same thing. It's just that if it's a square root, we normally don't write the little 2. If it's a different root, then we write the number, which we'll talk about in a second. Okay. So what is it? It's a number whose square is x. So the square root of 49 is 7 because 7 squared is 49. What do you think a perfect cube is? Not times 3. Right. A number that can be written as another number times itself times itself. Give me an example. 27. Why? Because 3 cubed, or 3 times 3 times 3 gives us 27. Give me one that's a fraction. Feel free to use this number again if you want. What's that? 8 over 27, yes. Because 8 is a perfect cube. And we can get 8 over 27 by going 2 over 3 times 2 over 3 times 2 over 3. And we can continue. We can talk about fourth roots, fifth roots, sixth roots. The same thing applies. So the sixth root of number is a number that times itself, number times itself, times itself, times itself, times itself, times itself, gives you that number under the sixth root. Okay? So cube root, let's just write this, of a number. Or third root, because it's got a little 3, is a number whose cube is x. So 8, if we take the square root of 8, we're trying to find a number that when we cube it, we get 8, and that would be 2. So the cube root of 8 is 2. And like I said, fourth root, what's the fourth root of 16? You can probably take a pretty good guess. It can't be a really big number. 2, because 2 times 2 times 2 times 2 gives us 16. Okay? What's the fifth root of 243? What do you think it might be? Can't be that big, because it's some number times itself, times itself, times itself, times itself. Any idea? What's that? 243. Some number times itself 5 times, that gets you 243. 30 times 30 times 30 times 30 times 30 is a lot bigger than 243. Sorry, I was going to say a bad word there. It's got to be small. 3. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. It's got to be small. What number or numbers can you take the any number root of and get an answer? No, I didn't ask that right. Is that, no, that doesn't make sense. Okay, here, I'll give you this one. What's the 100th root? Ooh. So some number times itself 100 times. What's the 100th root of 1? 1. Doesn't matter how many times you multiply 1 by itself, the answer's still going to be 1. So like the square, this is what I meant to say. The square root of 1, the cube root of 1, the fourth root of 1, the fifth root, the billionth root of 1 is always 1. Okay? We call these roots, and we're just going to focus on square roots and cube roots this year. Okay? But we call these roots radicals. Okay? So a radical represents the root of a number. What was that?
Oh, my God.
So like square root, cube root, fourth root, etc. And how do we tell if something's a root? Well, it's got this little symbol here, the check mark with the little horizontal bar. And it's got a little number outside to the left and above, and it's got a big number inside. Okay? We call the whole thing the radical. We call just this check mark with the bar, it's not very creative, the radical sign. The little number outside to the left is called the root, so square root, cube root, fourth root, fifth root, etc. And the big number inside, whatever that is going to be, is called the radicand. Do you have to know these definitions? No. But you should be familiar when I say radical sign, what I'm talking about. Or if I say, what's the index? Sorry, the root or index. I'm going to add that. Okay. Okay, so let's just look at a few examples. Ones that you should be able to do without a calculator, one that you're going to need the assistance of a calculator. It helps to know how to do square roots and cube roots on your calculator. Okay? So we should be able to get these ones pretty quickly. Square root of 81, cube root of 64. Oh, what's the square root of 64? 4. Let's all remain calm. Okay. So yeah, like 2-digit numbers, small 3-digit numbers, you should know their cube roots and square roots. Single-digit numbers. But once you start getting into high 3-digit numbers or even greater, let's use a calculator. Hopefully you are all familiar with how to use the square root button on your calculator. If anybody is not, make sure to ask. So find the square root of 1,296. You should get a whole number. You should get 36. The cube root of 1,728. Actually. Now, you may have this kind of button on your calculator, or it may be in the second. You have to do shift this. Or you may have something that looks like this, where you got a little x and a root y. So what you have to do is you have to punch the root that you want to take, 3, then punch this button, then punch 1728 and equals. That's most calculators. What do we get? 12? What? 12. Okay. So if you're not, remember, if you're not sure how to use it, Let's try this. Shift this.
Oh, maybe.
1728.
Oh.
Yeah. We okay?
Yes.
Yeah.
Is it this one? It's the next, though, not a 3.
Right. So you got to punch 3
Okay.
and then shift that button with that. Yeah.
Mhm.
And now punch 1728.
Like that?
Yep.
Thank you.
There you go. Ayla. Ayla. Okay. Perfect squares. Tell me the perfect squares between 10 and 50. 16? 25? Whoa. What's going on here? 16, 25, 36, 49, and then we're too big. Perfect cubes between 0 and 50. 4 is a perfect square, not a perfect cube. I heard somebody say 1. That's the first one. 8. 27, and now we're too big because the next one would be 64. These next ones, any strategy you want to find them. But if you're asked to find the square root or a cube root of a fraction, your answer should be as a fraction. Don't punch it into your calculator as a decimal. Take the square root and write the decimal. I won't give you full credit. If you don't answer this as a fraction. Ayla, stop it. Stop. Stop already. There, I've made you YouTube famous.
Subscribe right now.
For which one?
I'm trying to get the cubes function in, and I'm going. She told me to go 3 and then second function and then put that in, but there's 2 3s.
Oh, you don't. Yeah, don't. Just don't punch the first 3. Just go straight to that button.
Oh.
A.
17.
Whoa, 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 whoa. 17. 3 over 8. 3 over 2. Good. Okay. Here's somewhere where we use square roots and cube root. Oh, sorry, I'm jumping ahead of myself. Okay, this is going to make you think a little bit. Oh, what's the square root of x to the 6th? Oh, that's crazy. Remember what a square root is.
Oh.
Well, remember what it means. You don't need a calculator. No, you don't. Get off that thing. Ayla, stop it. Do what? Okay, think about it. What times itself gives you x to the 6th? X to the, hello? 3. Think of your exponent laws. X to the 3 times x to the 3 is an exponent law. Base stays the same, and you add the exponents. So you can take the square root of algebraic expressions, of exponents. You can take the cube roots, and etc. Using that same reasoning, what would be the cube root of y to the 12th? Y to the 3rd or y to the 4th? Well, if we go y to the 4th times y to the 4th times y to the 4th, that is y to the 12th. So the answer is y to the 4th. Yes.
Isn't 3 times 3 9?
But when we do exponent laws, we add the exponents when we multiply them. Ayla. Oh, again. Ayla, just stop. Okay. All right. Now here's where we can apply it. So we've got a square that has an area of 196 square centimeters. What's the perimeter? Step 1, remain calm. What do I need to know to find the perimeter of the square? Avery? Area doesn't equal perimeter squared. But that's if you were given the perimeter. Chloe? Don't divide it by 2.
You divide it by something and then square it.
Nor? That's for a rectangle. Okay. We need to find the side of a square. Well, if you're given the area, isn't side times itself going to be 196? So how do I work backwards from times itself? Square root. So to find a side, I've got to take the square root of 196, and I get 16 centimeters. That's not right. 14. Sorry. Now that I've got the side, I can find the perimeter. How do we find the perimeter of a square if we know its side? Times 4. So it's going to be 14 times 4, which is 56 centimeters. Not centimeters squared because it's perimeter, it's just length. Okay? We can use the same kind of reasoning when we're dealing with cubes. Now, we talked about how to find the surface area of cubes last year, but we never talked about how to find the volume of a cube. Okay? But I think you guys did that in middle school. Anyway, don't be shy. I don't know why that's there. To find the area of a square, we multiply the side by itself. A cube is 3-dimensional, so to find its volume, we multiply one of the sides by itself. Or in other words, the length of one side cubed. So we're given the volume of some cube. It's 4,913 cubic inches. We have to find the surface area. Well, in order to find the surface area, don't I need to know the side, length of one side? Okay. So the volume is equal to 4,913. Well, how do we find the volume? L to the third is equal to 4,913. So I need to find what times itself gives me 4,913. Or solve this equation. How do we get L by itself? How do you get rid of a cube? Cube root it. And whatever you do to one side, you got to do the same thing to the other. So to find L, we just have to take the cube root of 4,913. And that gives us 17. So 17 inches. Now that we've got the side, use the surface area formula to find the surface area. So you got to go 6 times 17 squared. Remember, do proper order of operations. Squared first, then times 6. $17 squared, I think, is 289. 289 times 6 is 1,422. I don't know.
1,734.
1,734?
Yeah.
Yep. Whoops. Yeah, inches squared, because it's surface area. Okay. Ayla, what are you doing? Why do you have a different calculator now?
Oh, that's mine. This is Rick's. No, I didn't do that. No, calculator, scientific information, privilege.
Is that yours or is that Reyes? So where's yours?
Is the other problems?
God. Any questions? Okay. So I see you guys Tuesday. Exercise 1.2, please.
Wait.
Oh, yes, I am.
Can we say bye? Bye. Like, comment down below.